Restrict the domain of quadratics and square roots to make a one-to-one function. A one-to-one function, notice one-to-one, or you can write it as 1-1, is when a function and its inverse are both functions. So if we think about square roots, or like that activity that we were working on, is if I have this one, or a point at 1, 3, a point at 2, -2, and a point at 1, 2, 3, 4, 5, 1, 2, 3, -1. So if I have that graph right there, notice it's a function. Whenever I graph its inverse, you should have noticed that a square root function and its inverse are also a function. So I'm going to go 1, -3, so I need to go -3, 1. Then I need to go, that one's at 2, -2, so I need to go -2, 2. And then 1, 2, 3, 4, 5, -1, so 1, and then 5, 1, 2, 3, 4. So notice the original is a function and its inverse is also a function because it passes the vertical line test. If I drew a line straight up and down, it would pass the vertical line test. So this one is a 1-to-1 because the original and its inverse are both functions. So another part of this definition is if original passes the vertical and horizontal line test, it is a 1-to-1 function. And what I mean by a vertical and horizontal is if the original passes the horizontal line test, when I take the inverse, then it would pass the vertical line test. This one also passes the vertical line, but that's what I mean by if it passes both. So if it passes both the vertical and the horizontal, when I take the inverse of it, it will be a function. So if we think about a quadratic, so if I had x minus 5 squared minus 3, and I graphed it, you can either graph it using so if I type that in, x minus 5 squared minus 3, oops, I've already, let's clear that, x minus 5 squared, is it minus 3? Okay, there we go. So you can either graph it using the table, and you would want to use these 3 points because it includes the vertex. Or if you remember back to transforming quadratics, I need to move 5 right, so 1, 2, 3, 4, 5 right, and 3 down, 1, 2, 3. And then over 1, over 1. And then I'm going to go ahead and do one more, so I'm going to do 3, 1. So 1, 2, 3, 1, and that point right there. Just so that I have a more accurate graph. Okay, so if that's my original, notice this is not a one-to-one function because it doesn't pass the horizontal and vertical line test. Because when I graph the inverse of that, and I'll do it on the calculator, so I'm going to hit second, program, go down to number 8. Then you need to tell it what variable or what function. So hit vars, go over to y variable, 1, 1, and 1. So notice when it graphs that, that inverse is not a function. It does not pass the vertical line test. So this is not a one-to-one. This is why the notes are called restrict the domain. We're going to change our domain or restrict our domain so that it is a one-to-one function. So this one is not a one-to-one function. And we're going to restrict it so that it is a one-to-one. So if you look at this, if I only graphed half of this parabola, so that's my axis of symmetry, that's at 1, 2, 3, 4, 5, so x equals 5. If I only graphed half of it, now you can, when you're doing this, you can choose which half. So I could either do the left half or the right half. I'm just going to do the right half. No, I'm going to do the left. So I'm going to do these points right here. So this point is at 5, negative 3. This one's at 4, negative 2. And this point is at 3, 1. And now I'm going to draw the inverse of those. So I need to go negative 3, 1, 2, 3, and 5. 1, 2, 3, 4, 5. I need to go negative 2, and then 4. 1, 2, 3, 4. And then I need to go 1, and then 3. So notice, if I only graph, oh, my computer just froze. If I only graph half of the parabola, so if I was only looking at this half, that would pass the horizontal and the vertical line test, and the inverse would pass the vertical line test. So notice this would be a one-to-one function. So you're going to restrict domain so that you only have half of parabola. So I'm going to get rid of almost this half over here. I'm not going to talk about it. I'm going to say that we're going to tell us, or you're going to use domain to say that I'm only going to use half of this. So only look at half. Other half, sorry. So that's the word other. Okay, so I'm going to only look at this other half. So remember when we talked about interval notation, the interval in which I'm going to look at, or the interval of the half that I'm going to use, would be from negative infinity, because it's this side, to our axis of symmetry, which is 5. So my interval would be from negative infinity to 5. You could also use, or you will also see that sometimes it's as an inequality. So I would say when my x values are less than or equal to 5. So I would say that it is this lower half from anything that's less than that right there. Anything less. So I would say the equation x minus 5 squared minus 3, either on the interval or using this inequality, that would then be a one-to-one function. Is now a 1-to-1 function. So that would be a one-to-one function because it would only include this left half. Now if I would have said x is greater than 5, I would have been looking at this half over here, and then it would have been the top half of this over here. So you just have to pay attention to, if I restrict my domain so that it's only the left half, then whenever I reflect it, it would be the bottom half of the parabola. If I did it this way, whenever I reflect, it would then be the top half. So it would be this half up here. So just pay attention to that. On your activity, you can pick which half you want. Just make sure that you only graph the part that you want, and then either the upper or the lower part. Square roots, remember, are already one-to-one, so you don't have to worry about those. You don't have to restrict the domain on those because it's already one-to-one.